Oh, what a day! What a lovely day!
Welcome to Flat Earth Debate Live. I'm your host Nathan Oakley, and if you are new to this channel, or you have not done so already, then be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. If you'd like to join the community debate, then go to nathanoakley.com and check out the Flat Earth Debate forum, which you should definitely all join. If you'd like to support the channel, there is a super chat that runs alongside each of these shows while they are live. There's also a PayPal, Patreon, and crypto link in the info box below the video. Most importantly, if you'd like to join the discussion right here, right now, simply mute the page you are currently watching, then click the link in the info box below this video to join the panel and express your views on the nature of Earth. If you do join, please don't swear. If you do, you'll be ejected, and if you are, please don't try to rejoin the stream using sock accounts. You'll be warmly welcome back on the next stream. Please also share the show on social media. Sharing the show obviously increases the live audience, but this in turn increases the chances of a more diverse panel, so please share the show on Facebook and Twitter. And one last time, if you're new to the channel or you've not done so already, then be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. Now we are joined by Quantum Eraser, Righteous Force and 10th Man in G+. Very good to have you.
Hello, hello.
Morning.
Good morning.
Good morning, good morning. We're also joined by a whole bunch of people in Discord. Hello, one and all.
Good afternoon.
Hello.
Good afternoon, good evening, wherever you may be. Any signs of Earth curvature? Don't all go at once.
Not in Mississippi.
Not in Connecticut.
Not in Dubai. Any signs of axial rotation of the Earth-based variety?
None at all.
It's amazing, really.
Not in Winslow, Arizona.
We have this effect that would easily demonstrate that the Earth was turning called Coriolis effect. We would expect to see some of this Coriolis effect. We'd expect to see a lot of this Coriolis effect on things like drones, helicopters, aeroplanes, all those sorts of things. So this effect, called Coriolis effect, should really prove Earth spinning. And yet it doesn't. It's amazing, really.
I think it's selective by gravity.
What, made up? No, Coriolis is real. It's definitely an effect you can observe. The not actual deviation of a drone as you rotate on a roundabout beneath it. If it's hovering and you're rotating beneath it, it'll look like it's flying towards you and flying away from you, even though it isn't. Well, that's Coriolis deviation. A not actual force, because it's not actually flying towards you when you're on a roundabout, you're moving. Well, the same principle would easily demonstrate Earth was spinning if it was. It's claimed by fundy globeheads that that's precisely what proves Earth spinning. Yet we just don't see any of this effect on helicopters, drones, anything beyond a 2-second hang time as they assert it, as Neil deGrasse Tyson does with things like footballs when kicked. Apparently Earth's rotating underneath them. But yeah, it doesn't rotate underneath drones and helicopters or basically anything, it seems. Hey, Owen.
Hello.
Yeah, but Nathan, you got to realize the Earth is rotating west to east in the globe model, but the only time you're going to see Coriolis in any way is north-south at the different speed lines as the speed decreases as you go towards the poles. Come on now.
Well, when you talk about the speed decreasing, the not actual deviation is observed if you're standing on the non-inertial reference frame or sitting on the roundabout, as I described it with the drone earlier. So when you say if you're travelling north to south, what exactly do you mean when the observation of this deviation is from the spinning reference frame? I don't really follow.
Well, this is where their west to east argument meets their north to south nonsense. They're saying the Earth is spinning or rotating, whichever way they like it, west to east. Okay, well, that means the whole Earth, north, south, middle, equator, every part of this model of theirs. But you can't experience Coriolis west to east like you can if you go north south, according to them. And the argument is when you go from the 1,038 mile latitude of the equator and you go low north, oh, now it's only 1,000 miles per hour at this point. And that 38-mile difference, that's where you're going to experience the Coriolis, because there's a 38-mile difference of location.
But again, you're describing the projectile or whatever that travels through the inertial reference frame in your description. Well, there is no observation of Coriolis deviation or otherwise when you're in the inertial reference frame travelling on a plane, for example. The observation of Coriolis deviation takes place on the non-inertial spinning reference frame. So this claim that it only occurs when travelling fundamentally is a demonstration of people who don't understand Coriolis effect, because it doesn't happen. You don't observe it whilst travelling through the inertial reference frame. It's observed from the spinning frame, like on my roundabout with a drone hovering over it. You see the drone seeming to come towards you. That's the effect. Not the drone sitting there doing nothing, hovering. It's not having to account for anything. It's just hovering.
Yeah, but Zanuck has this pretend couch or bench where the man is sitting watching all this, and he sees it differently.
Well, he would just see the drone hovering. There's no deviation to account for if you're sat in the inertial reference frame observing a drone that's hovering over a roundabout. You just see a drone hovering over a roundabout. However, if you're sat on the roundabout in the non-inertial spinning reference frame or on it, then you'll observe the drone seeming like it's flying towards you. That's the effect. So if he's describing something from a park bench in the inertial reference frame, well, that's not where you observe Coriolis effect. So he clearly doesn't understand what it is or how it works. That's just obvious. We've always known Zanuck doesn't know anything. He has to go to physics forums with our very troubling questions that he says we don't understand the premises thereof. We do. He just has to go and double check with physics forums for middle school students how to answer our troubling questions in regards to things like reference frames, which he clearly doesn't understand if he's detailing it from a park bench.
What about a cat that's observing the man on the park bench who's observing the drone flying over the rotating reference frame?
What about the cat? Will the cat observe Coriolis? Is that the question?
That's about as makes as much sense as their stupid argument.
But wait a minute, Tim Osmond
Got something even better than that.
How fast is the roundabout turning?
It doesn't matter. See, the quality rather than quantity of deviation is what you're looking for. So it doesn't matter if it's 1/1,000,000th of 1 centimetre because the roundabout's turning very, very slowly. Who cares? It doesn't matter.
Have better proof of Earth-based Coriolis than that. Anybody want to hear it?
Go ahead.
Okay, so I'm going to use a tall building as an example. Let's think of a skyscraper. So if you're at the top of that skyscraper and you're on a rotating sphere, with elevation, your speed of rotation increases. So if you're in the and can you hear me? I think I just dropped off for a second.
Yeah, you did for a
Yeah,
second.
you're cutting out.
If you're in what?
All right, let me start all over again.
Okay. No
I'm
worries.
going to use a skyscraper as an example.
Yeah, we're up higher. We're going faster with you so far.
Yeah, you're up higher and you're going faster. So if you take a ball and you drop it from the top of that skyscraper, it's going to follow a curved path. And this is because it's encountering an area of slower rotation, which is causing it to deviate as it goes down.
Have you done this test yourself?
Hold on. Okay, is that the end, Babs?
That's the end. And no, I haven't done the test.
No, that's okay. So you're talking about something that might stay in the air for 5 seconds, right?
Probably longer than that, just depending on how tall the building is.
10 seconds?
Yeah.
How long do you
Let's say
think
10.
How long do you think a drone can stay in the air?
As long as it wants to, or as long as the battery allows it to.
Half an hour?
Yeah, probably.
So if the Earth's
I
rotating
take it these
underneath at a
examples
greater
are
rate...
based on no
Oh,
wind.
my bad. I didn't realise I was in the middle of a conversation. Go ahead, Highlander.
I was just asking, I take it these examples from both sides are based on no wind.
No, I hadn't quite finished my example. So, given that your example, Babs, would be that you see a mild deviation on account of the fact there is a difference in circumference when you decrease your altitude, i.e. drop a ball off a skyscraper. Therefore, a mild deviation would be observed because the Earth rotates underneath at a different rate as you drop it. Well, I would suggest that, given that a drone can stay in the air for about half an hour, you'd see a lot more Earth rotating underneath it if Earth was rotating underneath it. Would you not agree?
I do agree, yeah.
So these little hang time examples of 5-10 seconds, or a bullet, couple of seconds, or a football, 2 or 3 seconds, they're just ways of introducing this effect that isn't demonstrated in things that have an exponentially longer hang time. It's just they're crappy examples. Why not use an example that's in the air for a long time that shows massive amounts of deviation? Oh, I know, because you'd have reduced flight times when travelling west.
Different.
Well, you just have reduced flight times. If Earth's rotating underneath, then you travel, as in QE's example, from Charlotte, North Carolina to LA, normally about 4.5 hour flight time. Well, that would take an hour and a half because Earth rotated underneath, because it's got a nice long hang time to see that effect that's causing the ball to slightly drift in your example. Well, it wouldn't be a slight drift. It would be the continent or country or place that you're travelling to in the west coming towards you if you're travelling towards it. Really obvious. The problem being that doesn't happen. But the examples we get given have these very short hang times, and then when it comes to there being something with a long hang time, they go, well, that's got a motor on it. Like a drone on a roundabout that I exampled earlier coming towards you and going away because it's hovering over a roundabout. That motor makes no difference to whether or not it seems to fly towards you and seems to fly away as it hovers over a roundabout. The motor makes no difference. But that's the Fundy Globehead argument. Oh, that's got a long hang time and should have massive amounts of claimed deviation when watching it from the ground. But also, because of the claimed deviation, it should be reducing its travel time, but doesn't. Oh, it's got a motor. That's their best get out. Even though it makes no difference. Like I say, drone on a roundabout, it's not going to not have Coriolis. It's not going to track with the roundabout just because it's got a motor. That's nonsense.
Yeah.
Did you get that, Highlander?
To answer Highlander's question about whether atmosphere is involved or not, you could drop that ball through an elevator shaft in that building just to make sure that there's no winds that are affecting it. And with a drone, you have to take into consideration that the atmosphere is rotating as well. And the drone is also maintaining tangential velocity.
That's a very interesting point. So when they drop the feather and the bowling ball, it should be deviating, right?
That is an excellent point, yeah. And we don't see that happen.
That's interesting. That's because Earth's not spinning.
Yeah, that's because Earth is not spinning. And probably because the bowling ball and the feather are not dropped from high enough for you to notice anything.
Nah. What about a drone? That hovers for a while. Seems to come back down in exactly the same spot, though. So weird, that, isn't it? You'd think Earth would be turning underneath for half an hour, and yet it comes down where it took off from, even with wind half the time.
It does, but Earth's atmosphere is rotating, and the drone is also maintaining tangential velocity.
That's
why it's staying in the same.
Yeah, it's not the case, though. Neil deGrasse Tyson, high priest of scientism, asserts that you kick a ball from the ground and it leaves the non-inertial spinning reference frame and demonstrates Coriolis as you're asserting should be demonstrated with a ball when dropped. So no, it's nothing to do with Earth and atmosphere travelling as one. Otherwise Neil deGrasse Tyson's example simply wouldn't work. But he still declared it via Twitter because he thinks Earth does spin underneath.
And can he please explain how gases rotate with a solid body? Thanks.
Was that one for me?
Yeah.
Gravity.
It's gravity.
That's how it
Sorry.
works.
No. Let's just nip that. Let's nip that in the bud. So no, the bending of a conceptual medium to give rise to a non-force that you can think of as a force but is not actually a force called gravity isn't going to defy how gas behaves.
Well, you can
Gases aren't attached
think
to
of it that
themselves.
way.
Gases aren't attached to themselves, making them a gas, let alone being attached to anything else. So how in the world is it spinning with the Earth, please? Moving in random directions at high speeds. Please explain.
I'm just Googling the answer right now because I saw a really good answer for this yesterday.
Really? I can't wait.
Let's see here. Here we go. The
Morning.
pressure of
Good morning,
gas
guys.
is
Can you hear
defined
me?
as the force.
Hold on,
Yeah.
Chocolate. Hey, good to have you. Do you want to start again, Babs?
All right. The pressure of gas is defined as the force the gas would exert upon a surface or a container. However, there is no need for a container for pressure to exist. For instance, the air you're breathing right now, unless you're in an airplane or submarine, has pressure due to the column of atmosphere above you.
Okay, this column, right? What is gas? How does gas behave?
It moves in all directions.
Okay, so it's moving randomly at high speeds in all different directions, but you have a column of air. Isn't that a violation of the law of non-contradiction?
I have a
I've
column
got it
of
on my
air because gravity forms a density gradient.
No. Don't go away from my question.
No.
I
I covered
said,
this. Sorry, John. I just covered this. So the bending of a concept, in this case, a medium called space-time, is giving rise to a non-force that you can think of as a force but is not actually a force called gravity. Now, bending conceptual mediums doesn't defy gas law. Just to cover that second time. Go ahead, John.
yeah, but regardless, like I said, you can have both of the Wonder Twin powers activate at full force, and it has nothing whatsoever to do with the argument or my position or the question that I just asked you. Let me state it again. How can you have gases traveling at high speeds in all random directions and at the same time have a column of it above your head? You're holding two mutually exclusive positions at the same time. It's a law of non-contradiction violation. Thanks.
Because of that happens because of gravity. Are you trying to say that
Third time.
Oh my
you guys
God.
are trying
Third time.
you're trying to contradict Einstein and the theory
Einstein's
of
concept.
relativity?
Einstein's concept. So Einstein's not maintaining gas, and his concept of a medium called space-time doesn't do anything here. Do you understand that? This bending of... Let's pretend that instead of the conceptual medium of space-time, we talk about freedom. And I rebut John's claim by saying, but if I bend freedom, gas law no longer applies. Well, no, you can't bend freedom and you can't bend space-time. These things are concepts. They're not going to stop gas doing what it does.
But can't you just bend
What
the
causes-
natural law a little?
We're off topic.
What
That's the
causes
third.
pressure on the flat Earth?
That's the third time. You haven't addressed his rebuttal. So I'm going to summarise John's rebuttal. He's saying that a column would be homogeneous and the gas is inhomogeneous.
Right. So because the gas is homogeneous, a column can't form above us?
No, it's all mixed up.
Why can't...
Not collimated by definition. Inhomogeneous.
Right, then why is it that when we observe gases...
It's not...
Go on, Babs.
Why is it that when we observe gases in containers, they form gradients? Why does that happen? If they're moving all over the place, why do gradients form within containers?
What in dynamic systems, when there are other forces at play? Yes, you can manipulate gas behavior.
What other forces are at play?
Who cares? It doesn't change the behavior of gas. It doesn't form columns.
Hey Nathan, if you can share my screen, I'm manipulating the motion of particles and reducing the pressure on my little...
Okay,
fun
sure.
little gift here.
Can you go to the live stream, Babs, so that you can see what I've presented from Paul's screen share? And then when you've got it on screen, just let me know.
I'm looking at it right now. Yeah.
In this mess of inhomogeneous dots, where's the column that you might decide to describe in this inhomogeneous, mixed up bunch of dots? Can you see collimation potentially forming?
No.
But if he opens the top, if you would for me, Paul, you notice how the black section at the top has got quite spread out particles as it fills the available volume. Now, if this was water particles, potentially turning into gas particles and going up to the top, and the puddle at the ground was where the highest concentration of that water was, would you accept that there'd be less at the top than there was at the bottom?
Repeat that again, please.
So if this representation was water, you were looking at a puddle, and it was being heated, would you accept that there'd be more concentration of particles at the bottom, because that's where they're being formed, than there was 30 meters above, where 20 minutes later one particle might reach? Therefore,
I do
radiated.
It depends on whether the gases are being formed at the bottom of that container. If they aren't, then over time, the container would just empty out. But
I see.
If the gases are continuously being formed, then yeah, that would happen.
So, of all the gases that are produced here on Earth, how many are produced halfway up in the sky somewhere? Or are they all produced on the ground?
As far as I know, they're all produced on the ground.
Excellent. So akin to my example of them being produced on the ground and thinning out as they go up, that would be a natural and normal and logical explanation for this gradation that you describe, would it not?
Yeah, perhaps you could say that.
Excellent. That's the end of that one. So no columns. Notice we didn't describe columns at any stage.
And you notice too, I don't know if you watched what I was doing. I was reducing the pressure in the container by just reducing the temperature. So you see that? And I increased the temperature, and the pressure increased. As if I apply more pressure, more temperature, even when there's so few particles in there, they start to move out more fast, more rapidly. You see that?
Yeah, that's entropy. But what's the difference between columns and gradients? I know they're two different words, but aren't they similar?
It depends. When you're asserting that a column's pressing down from above, and that's why you don't need a container, as per your citation, then we would point out that no, it's gradiated because the concentration of gases is produced at the ground level. It won't give you a collimation, and it absolutely will still require a container. The V in gas law. PV nRT. No G.
Okay. And the container would have to be solid. It couldn't be a gas container.
You tell me. So if we exclude the walls of this container, how many of these particles are containing the other particles, would you say?
Probably none, but don't the particles lose energy the further they travel? So wouldn't they be slowing down as they go higher up?
Not exactly. So the energy dispersion increases. The overall energy stays the same, but the dispersion of that energy would increase. In terms of entropy is increasing as you're watching it now. So the energy hasn't changed. You're just seeing it become more dispersed into the available volume. Entropy is increasing.
Well, if you notice too, even the
hold on a second, Paul. Is he saying that gas molecules stop moving?
I don't. That's good. That's a good
That's
point.
what I'm saying. Are those little tiny balls that we're looking at right now going to be moving at the same speed the further they travel, or do they slow down?
Yeah, they ain't gonna stop. Then it wouldn't be a gas anymore.
Well, and then also, if you watch this,
Are they speeding up?
If you watch the gift, there's different particles are moving at different rates, and if you look at the temperature, it's like negative 263, but the particles are still moving.
Oh, hold on, Paul. That's not the point. I appreciate you saying that it's correct, but that's not the point. Will they stop? No.
They're never going to stop. They're just going to keep moving.
They'll never stop. No. I can't do it when I'm giggling. I can't get the Terminator references out quick enough. There's no reasoning with them. There's no bargaining with them, and they absolutely will not stop.
Right. Okay, so we definitely can't have a column of air above us. That's just not possible.
It's a
That's
violation.
right, because of the contradiction I mentioned in the beginning. That's right. You also mentioned the theory, Einstein's theory. Is that a scientific theory, by the way?
You tell me.
No.
I'm not telling you.
Huh?
You said theory, Einstein's theory in relation to gravity. You tell me.
Why don't you guys have Nobel Prizes right now if you're contradicting?
That's a procedural argument
science.
rather than one of substance. Now, can you answer the question?
Define science.
Hold on.
Oh, he's got into character. He's rumpusing you. So the question on the table. Do you want to repeat it, John? Go ahead.
Yes, he mentioned Einstein's theory in relation to gravity. My question was, is that a scientific theory?
Science.
Said science. Say again.
Actually, you know what? Define a scientific theory. Because that's what you're asking for right now.
Rapidly do that, no problem. So scientific theories are based on applications of the scientific method that have been validated through systematic experimentation. So after, it could be one, but typically multiple adherences, if that's the right word, to the scientific method that have been validated. Once you have those empirical validations, you can put together scientific theory. So it's based on valid experiments.
It's hypotheses or a group of related hypotheses that have been validated by systematic experimentation.
That's a just for clarity. Just for clarity, sorry. That's a scientific theory, as opposed to a mystic Meg theory.
Okay.
Or a Big Bang theory.
Of multiple different scientific methods. You're trying to tell me that there's only one scientific method?
That's right. There isn't multiple scientific methods. Like I've been saying for many days now. You have three indispensable steps in the scientific method. That is, observe a natural phenomena. That's where you get your dependent variable. Hypothesis. That's where the independent and dependent variable are stated succinctly in a supposition. and then experiment, where you add control or constant variables to that previously mentioned independent-dependent variable supposition in the hypothesis. If it doesn't contain those 3 steps, then it's not the scientific method. Thanks.
Not thanks. So, back to the original question. So, does Einstein have that?
I would say yeah, because he is studying the natural world, and
share my screen.
He's studying gravity, which is a phenomenon in the natural world.
Thank you.
The only difference here is that he's not performing experiments.
You'll have to zoom out.
Okay, we're ready.
Hold on a
second.
Ready. Let's get control. So you'll have to zoom out a little bit. It's a little bit zoomed in for some reason.
Say again.
Can you zoom out?
Zoom out.
Not a possibility.
Hold the control keyboard and scroll back with your mouse.
Ah! What's happening? Oh no. This started so well.
Yeah, it did.
Control minus.
Where'd you go?
Looking rough.
Do something about this.
See it properly.
Is it better?
Nah, not really. We can see from the number 1 on the blue writing. Oh well.
John, just hold the control key and press the minus sign.
My word. Let me see where I'm at here. All right. This is a big file. I need to square this away. All right. All right. Natural phenomena observed, please.
Can't you zoom out?
What do you mean?
Try again, Righteous.
Natural phenomena observed is objects
hold on
fall
a second.
to the ground.
What's the problem here, Nathan?
Can't see it. It's too zoomed in. You need to zoom out.
On your keyboard, John, hold the control button and then press minus sign.
No, it's not working. Now we're getting it's all screwed up now. So is that good?
No.
Jeez, oh man.
All right, I'll fiddle with
Yeah,
mine.
You just need to move the chat out of the way.
It's fine. If you can make it bigger again, make it. Just one at a time. Make it bigger again.
You've got it there.
Oh God, everybody's going to talk over me. If you can just make it how it was again, bigger, please. Control and then plus. There we go. That's fine. Now we can see everything. Happy days.
That's where it was before.
I made an adjustment. I think technically this is entirely all my fault. But if we can brush past that quickly. Right. So on you go.
I'm on move.
Natural phenomena observed, please.
Right, so natural phenomena observed is when we pick objects up, they fall down when we let them go.
Okay, objects
because of a force.
Hold on, you've got to give him a couple of seconds to write it down.
Don't bramble. Pick objects up, then fall down, go, boom, boom. Okay? Good. All right. So this is your dependent variable. So fall down, go, boom, boom.
Am I allowed to change that? Because I feel like I put myself in a trap by saying that. So I want to change it a little bit.
All right. No problem. Natural phenomena observed, please.
Objects with mass fall to the ground.
I thought I was going to get a coffee. God damn. What's mass?
If I said I picked it up, you're going to say that I'm the one that caused it to fall to the ground.
No,
so
that's not what I asked. I just need a definition of something. Sorry to interrupt, John. Just need a definition of this word. I've had a lot of trouble with it over the last few days. What's mass?
Oh no. The mass is the amount of matter within an object.
God damn. That's a mole.
What?
That's a mole.
Yeah, it's
Kidding
not
me, really?
Yes, that's really a mole. Yes.
Mass is not quantitative. It's mass.
Oh, what?
No, it's not.
Hold on. We've got a... I'm going to go get a coffee. Who's dealing with this?
Oh, here, I'm going to help you out. No, but it's a mole is a specific amount of something, or specific number of something.
Maybe I can help him out. A natural phenomena observed is nah.
That's not really helping right now. Arwin.
Oh.
I'm looking at the definition of mass here, and it says that it's a coherent, typically large body of matter with no defined shape. That's kind of similar to what I just said, right?
It doesn't seem like the scientific.
Where are we going here? I'll tell you what. Let's give him mass. All right. Let's just give it to him. Objects with mass fall down, go boom, boom. All right. What is the independent variable? What is the cause of that?
What is the cause of that? Gravity, the force of gravity.
Okay, so you're trying to prove gravity. What the heck? You're trying to prove gravity, correct?
Correct.
Einstein, and that is what you're using as your proof. Do you understand what a begging the question fallacy is?
I'm assuming the outcome of what this is going to be before knowing what the cause is.
Your conclusion contains one of the premises, and your premise is gravity. What's your hypothesis, please?
Hypothesis is that we observe that objects with mass fall to the floor because of a force called gravity.
So gravity causes objects with mass
While you're typing that out, shout out to David Racky at Gafford. He says, I pass, so should this guy. I'm on mute. God is creator. Racky alive. Very funny. Shout out to David Racky at Gafford. Thanks for the super chat.
Can I ask for clarification on mass?
Oh, we got
clarification on mass.
Yeah. So is the conclusion that
sorry, wait. Just we've given it in for now, so I just want this to be concluded before we get back onto mass. If I'm going to have it stolen from me, God damn it, you're not having
it. Okay, here's your hypothesis. You're trying to prove Einsteinian gravity. So gravity causes objects with mass to fall down, go boom, boom, go splash, splash. This is a begging the question fallacy. You haven't done anything yet. What is gravity?
Let me just check. Do you understand
a fictitious force or a pseudo force?
Before you answer his question, do you understand what he means when he says begging the question fallacy in this specific regard? I know you've detailed what one is, but do you understand how this is assuming the outcome? The thing you're trying to prove being gravity and it being your independent variable, akin to me saying, I'm going to prove unicorns by varying the number of unicorns.
I do understand what he means by that. It's that I'm begging the question by assuming the outcome before actually performing any experiments to know what's really causing that to happen.
Well, you can't perform any experiments because gravity is what you're trying to prove, and you can't manipulate a fairy tale unless you can show me some gravity that you can manipulate.
Can't, no.
That's what I thought. And what does this have anything to do with Einsteinian gravity?
I was making the point that if you guys are contradicting mainstream science, why haven't you come up with any theories that can go against
mainstream science is contradicting itself.
We don't have to come up with a substitute theory to pummel theirs, and there is no mainstream science. I think we're done here. Go on with math. Thanks.
So if we don't come up with alternate theories, that leaves us with nothing. We
Alternate theories to what?
try and understand what's
the
going
main
on
one
here.
that we've altered from?
Can you
haven't
repeat that?
given one
You're
yet,
breaking up a
so-
little bit.
You haven't given us a theory. Like I said, we don't have to provide a substitute theory, quote unquote, to pummel yours, and you don't have one. So you can move on to mass now, Nathan.
So what's mass? Didn't the dude in
mass?
Sorry, he's on Discord. He's on server mute at the moment. Damn it! Dances with Fools was the guy who wanted to ask questions in that regard. Oh, he can hear us now. Dances with Fools. Did you have something you wanted to say in regards to mass?
Yeah. So the last known definition by Babs was, if I understood it right, is that mass is just another word for stuff. That's a question.
Babs? That's a gap, I'll take it. Shout out to Prince Tactics. If there's another option available to speak to Discord if it's full, I've just moved somebody to the after show. Hopefully they won't just immediately jump back in again, because I'll just move them again because they're not talking. But yeah, I'll just move a few people out into the after show if you want to try now. There should be a couple of gaps. There is a couple of gaps. Thanks for the super chat. Do you want to address that, Babs? Hopefully I haven't stolen your thunder. Dances with Fools.
So the question was, so am I to understand that when Babs, if I'm not mistaken, when they said mass, is that just a different word for stuff or matter?
I'm having some audio issues right now. I'm gonna have to get back to you in a sec.
You've missed a step. You missed out. You don't understand.
This is silly. One is just a general terminology in daily use of words, and the other one is actual physics definition. So, is this gonna lead anywhere?
I don't know. We've still got this experiment, but it's going through a tunnel, so we'll have to move on, I think. Once the 1989 connection problem's been solved, just let us know, Babs. Is mass... So there's an open-ended question now from Dances with Fools. Is mass just stuff?
Who's he asking?
Anybody.
No.
Mass is also synonymous to multitude, I think.
I have a question when you guys finish. Sorry to interrupt.
Don't know if that was a satisfactory answer for Dances with Fools. Is mass stuff? No. There you go.
Basically, yeah. It's the amount of matter contained within something.
That'd be a mole.
That's what I said. Mass is the amount of matter.
Is a mole not a specific number, though?
What? The number of stuff in stuff? Yeah, mole.
A mole, but a mole is a specific amount of substance that contains. Yeah, a mole, but mole is the amount of substance, right? It doesn't much matter. It's the same thing, whether it be a specified amount. It's still an amount, right?
So basically, you could use either terminology then.
Well, when you say the amount of stuff in something,
what are you referring to? Are you referring to molecules, atoms? The amount of what substance are you talking about?
It doesn't matter. Let's just settle this right now. From the Royal Society of Chemistry, studies have shown that the amount of substance is often incorrectly identified with mass. So that ends that. Do you have another definition?
I just wanted to know what substance you're referring to.
Doesn't matter.
Does it not matter?
It doesn't matter in the context of our discussion right now. If you want to get specific, it's Avogadro's number of elementary entities, but it still doesn't matter. It's the amount of substance.
Well, maybe it does. So given that you've got this specific number of elementary entities, is there a comparable number for mass as opposed to mole?
Yeah, kilograms.
Do I have to say the definition over again from the Royal Society of Chemistry? I got to repeat that?
But isn't kilograms just a conventional way of measuring weight?
I'm going to go with yes. Yes, please, QE.
Moreover, studies have shown that the amount of substance is often incorrectly, that means it's wrong, identified with mass.
What is mass then? I'd like to know what your definition of mass is.
You're asking me what mass is. I love it. I love it. You just put it into your hypothesis 10 minutes ago. Highlander, did you hear that?
I did, yeah, but I was under the impression that...
Not you, Babs. Not you. Highlander. You asked if it's not just the amount of stuff.
Highlander's not here anymore.
Oh, bummer. Didn't he want an answer? Why did he ask? What the hell?
Okay. Any other question?
We're still on a point. We've got collimated air being held by non-force forces that you can think of as a force called gravity that's a bending of a conceptual medium. And then we've got into this describing mass, presumably so it could be attributed to gravity. That was where Babs was going. I don't know why it's petered out the way it has, but it has.
Well, I was talking to to Virus in chat, and he says an airplane proves that you can have gas pressure next to a vacuum. Literally, he said that.
Wow.
No, what he's... it's okay. I don't mind making his argument for him. He clearly doesn't understand his own argument, but he's got pieces of it from somewhere else that he hasn't put together in the correct order. He's talking about a differential. So if he was to formulate his argument with some sort of... What kind of fallacy is it, first of all? It would be a straw man fallacy. So if he was to formulate his straw man fallacy correctly, he'd say, you can create a gas pressure differential underneath a plane wing. There's no container needed. That's the straw man.
I know exactly where he got this argument from.
Let's just unpick it, though.
Argument.
So what we have in the first instance, before the plane does a damn thing... What do we have before anything happens in regards to this differential? Oh, we've got gas pressure to begin with, haven't we? And where did we get that from before we do anything in terms of changing that gas pressure? Oh, we'd definitely need the antecedent of a container first, wouldn't we? So where do we get the gas pressure from in the first instance for you to start pushing wings over it and creating differentials? Where do we get the gas pressure from in the first place? What's that you say, Fundy? Not important? Yeah, it is. Because it's the necessary antecedent to have the gas pressure in the first instance for you to start messing around with it to create differentials.
And the definition of a the definition of a vacuum is at differential pressure. It's little or no substance. If you share my screen, that little box is a vacuum. There's virtually no substance in it.
So right? Little or no moles.
Well, his claim is the atmosphere does not need a container, and I asked him to demonstrate it, please, and he can't.
Let me try to demonstrate it for him.
I just thought of something.
I've got a vacuum. Let me see if I can do gas pressure in a vacuum. Here, hang on. Let me see how long this lasts.
Oh, it's already failed. We'd need it to stay in the square.
Seems. I'd like to add something. I just thought of something right now because John.
Well, stop your. Oh gosh, this guy.
He has tried 2 or 3 times, 10th man. Go on, Babs.
He's had the floor for the last 30 minutes.
That's true.
Yeah, go ahead, 10th man.
No, I want to hear the nonsense. Make me laugh.
Go on, Babs.
Okay, I just thought of something right now. 10th man said that my independent variable was assumed to be gravity, so you can't assume your cause. Is that correct?
10th man didn't say anything.
Well, I'll just correct.
I was talking to John, not 10th man.
I don't mind who it was. As it wasn't 10th man, I'll just address it. So, no. Number 1, your presumed cause, which is a presumption, has to be real. Number 2, it has to be capable of being varied and manipulated by you, the researcher. Number 3, it is your presumed cause, your independent variable. So it must be real, you've got to be able to manipulate it, and it's your presumed cause. If it fulfills that criteria, then you're all golden. Now, is gravity something that you've got that's physically real, that you can show me you varying and manipulating it by chance?
No, it isn't.
So it's something you're trying to prove as real,
However,
as opposed to something that is real that you're presuming causes something else. So no, it fails as an independent variable because it's not real. You can't vary it.
But John also said that you can't assume what the cause is without proving it first.
Wrong. I didn't say that. You needed to watch the last science presentation where I went over this exact subject. Right? The independent variable isn't presumed. It should exist. It's the independent variable and its effect on the dependent variable, which is the supposition. You have the wrong emphasis on the wrong syllable. Thanks.
May I example this? So you have, you're trying to find the cause of boiling water, and you have a presumed cause of, let's say you're going to try a few things, see which one works. You're going to try acid, because it's real and you can vary it. You're going to try heat, because it's real and you can vary it. And you're going to presuppose that unicorn farts are causing it, because they're real and you can vary them. Which one's the unreasonable one in that list?
Unicorns.
Right. So gravity being something real and variable and manipulatable, or something that's just being presupposed as the independent variable in this instance, i.e. begging the question?
Yeah, he just answered my question, and you did as well, because I thought that he said that it can't be something presumed, but you just answered it by saying that it has to be something real and it has to be something that you can manipulate.
So yeah, when you say has to be presumed, it's just maybe an error in comprehension on yours and many other people's parts. It is your presumed cause. It being something real that you can physically manipulate, as opposed to my presupposition that unicorn farts are real. So it, the thing that's real and you think causes the effect, is going to be varied and manipulated to check if it does cause the effect. Because it, the real thing you're varying and manipulating, is a presumed cause of the effect. It's not that something that isn't real you'll presume is real and then call it an independent variable. No, it's got to be varied and manipulated by you, the researcher. So it has to be real.
And it was what he was attempting to prove, making it a classic begging the question fallacy. Before you close out, I would just like to, I don't want to, lest we forget, there is a request. Oh, God. Okay. There is a request on the table for an astronomer and we've branched out a little bit. We've gone to this twisted little sisters, cosmology and astrophysics too. So we need an astronomer or an astrophysicist or a cosmologist to provide us one hypothesis in the entire history of either discipline. One viable scientific hypothesis. Thanks.
And with that, I'll say if you are watching this on the Nathan Oakley premiering stream, then stay tuned as there will be an after show to follow. Unfortunately, if you are watching this live on Nathan Oakley 1980, then this is where we bid you farewell. Be sure to check out nathanoakley.com though and the Flat Earth Debate Forum to keep up to date with the community debate. I've been Nathan Oakley. Stay tuned if you're watching on the premiering stream on the Nathan Oakley channel, and I'll see you all in the next video.
Oh, what a day! What a lovely day!